Okay, so welcome everybody. It is really awesome to have all of you here with us again this Saturday afternoon for our second session of exam prep. And you would have been sent the exam prep document before the time and hopefully had a chance to look at some of the questions and at least work through them and try them. The downfall, I suppose, of the questions that we're going to do today is that when it comes to analytical geometry especially, we need to have done the first questions in order to answer the ones that are down below. So it's often not possible to like skip this one and just go straight to that question over there. But before I jump straight in, are there any questions that sort of particularly jumped out to you as being difficult or that you weren't able to do? This is now in question 4 I'm talking about specifically. Question 4.2 and 4.3 says Aisha. Okay, 4.4.3.
Yeah, I'll agree with them, ma'am. It was a bit tricky. I did figure it out, but 4.3.2 was pretty.
All right. So what I'm hoping, Matrix, what I'm hoping is that you did find these questions at least a little bit challenging. You know, I don't want it to be so easy that it's so difficult that it's like unmanageable, but I do want it to be a little bit of a challenge for you because that is certainly what we can expect in our tests and in our exams. Okay, so let's get started with question number 4, and let's talk about how we would approach this. All right, so in the diagram, they've given us P, which is the center of the circle, and the coordinates there are -3 and 4. P is a point that's located in the second quadrant. V is a point on this, yeah?
I just need to ask, are you supposed to be sharing your screen at the moment?
Am I not sharing?
Not at all, ma'am. We've seen your lovely face. It's great to see your face.
Okay, all right, hang on a
But
second.
we do need you to just screen share for us.
Of course you do. Of course you do. What am I doing? Hang on. How? Sorry. How stupid am I?
There we go.
That's
awesome.
better. Okay, sorry guys. How ridiculous is that? Okay, I'm sorry. I thought my screen was being shared. I beg your pardon. Okay, there we go. So question number 4. P is the center of the circle at the coordinates -3 and 4. It's a point in the second quadrant. V is a point on the circle, as is W. They've given us the coordinates at V being K and 1. So that means the X coordinate is missing, but the Y coordinate is 1. They've also told us that the circle intersects the Y-axis at B and C. So those are Y-intercepts. And the other thing that they give us, a little hint, they say that BCVW is a cyclic quad. So I chose this question on purpose because the other day during class, we were talking about cyclic quads and how Euclidean geometry links to this, etc., etc. So I actually did this on purpose because they ask a question about it here and I wanted to show you that. And then the last thing that they tell us is that CV is produced to intersect the x-axis at T. So they've just extended that line, and that means that angle OTC they've called alpha. All right, so first question 4.1, the radius of the circle is √10. Calculate the value of K if point V is to the right of point P. Clearly show all calculations. So now none of you said that you struggled with this question in particular. Can someone tell me what formula did you use to determine the value or values of K? Anybody willing to say? Remember, √10 is the length. It's the length of the radius. Okay, so Aisha, you said circle radius formula. Okay, so that would be the circle, all right, would be center radius form. Can you see this? Same here. Okay, maybe I'm not putting my questions. Mind you, I suppose you could do that. What I did is I did this. I worked with, you found the equation of a circle. Same, then quadratic formula. Okay, all right. So this is what I did, all right. I said that, just get a pen here. If the radius of the circle is 10, all right, then it means that subbing into x minus a squared plus y minus b squared equals r squared, we would end up with k plus 3 squared plus y minus 4 squared equals 10. And what I can also do, I should have done it at the same time, is I should have substituted in the value of y at the same time. Sorry, I'm being a bit blonde here. Okay, so I've substituted point V into the equation of a circle. Okay, so x minus a squared plus y minus b squared equals r squared. And it is essentially, yes, Michael Sandile, it is essentially distance formula. It is. That's exactly it. All right, and now we will be able to multiply out and solve for k. So we ended up with, let's just do this quickly. We ended up with k squared plus 6k plus 9 plus 9 minus 10 gives us 0, which means that when we got it into standard form, we ended up with k squared plus 6k plus 8 equals 0. And then when we factorized, we had k plus 4 times k plus 2, which gives us 2 possible solutions for k. Either k was equal to -4, or k was equal to -2. But they did tell us that v is to the right of point P. So if v is to the right of point B, it means we need to choose the smaller of the two, sorry, the larger of the two values, which is -2. So thus it cannot be equal to -4. All right, so everybody happy with that? That was quite straightforward. Even though it was 5 marks, it wasn't a particularly difficult question. Question 4.2 now, all right, they're asking us, good stuff. They're asking us, the equation of a circle is given as this, calculate the length of BC, all right. So now, essentially what they're asking, cool, Aisha, I'm glad that went well. So if they're asking us for the length of BC, they're really asking us for the difference between the y-intercepts. And even though this isn't, a circle is not a function, we would still say that at the y-intercepts, the value of x would be equal to 0. All right, and that's exactly what you would do for 4.2. All right, you need to make x equal to 0. So subbing into the equation that they've given us, so here for 4.2, we would sub into 0 squared plus 6 times 0 plus y squared minus 8y plus 15 equals 0. Okay, and obviously those first two terms would become 0. Y squared minus 8y plus 15 we can factorize. So that would be y minus 5 times y minus 3 gives us 0. So either y is equal to 5 or y is equal to 3. All right, and that makes sense because, I mean, if we go and we look at the diagram, 5 and 3 seem like reasonable answers. All right, so therefore the length of BC, okay, so well, let's rather do this. Therefore the coordinates at B have to be 0 and 5, and the coordinates of C have to be 0 and 3. So therefore BC is 2 units. Okay, so also not a particularly difficult question to have to answer. So we're feeling good about the first 9 marks. Now they say to us in 4.3, if k is equal to -2, calculate the size of alpha. All right, now, why do you think they gave us or wanted us or giving us a hint here to tell us the x coordinate at k is -2? How does that help us calculate alpha? What do we need to do here? How are we going to calculate an angle? Absolutely, from gradient, Kayla. Okay, so here we're working with tan alpha equals m. All right, is it okay if I rub off 4.1? Yes, all right, so I'm going to rub off 4.1 and work here. Okay, so now we know that the coordinate here is -2 and 1. And we also know what the coordinates at C are, don't we? Because we've just said that that is 0 and 3. So as you had said, that means we can work out the gradient of line BC. And tan alpha will be equal to the gradient of line BC. So that's how we're going to work out that. So it's also not a particularly difficult question. All right, so in 4.3.1, we have tan alpha, and that's equal to gradient. So let's do gradient 3 minus 1 over 0 plus 2. Not like the other day where I couldn't take 1 away from 3, which is ridiculous. But anyway, so 2 over 2, which means we get a gradient of 1. All right, so from special angles, you should all know that the tan of 45 degrees is 1. So therefore, alpha would be equal to 45 degrees. Okay, nice question. Now 4.3.2. 4.3.2. This is one of the things I really wanted to talk about today. VWB. So now, guys, that's this angle up here. And when we have a look over here, it's only worth 2 marks. So it's got to be something fairly simple and straightforward. Now, we don't have any parallel lines, so we can't use alternate or corresponding or anything like that. But what we do have is a cyclic quad. What do we know about cyclic quads? There's 2 things that we must know about cyclic quads. There's 2 properties of cyclic quads that are important to us. The first one is that the opposite angles of a cyclic quad are supplementary. So what that means for us in terms of this diagram is that if we added W to C, we'd get 180. Or if we added V to B, we'd get 180, but that doesn't really help us. Yes, opposite angles of a cyclic quad are supplementary, absolutely. Doesn't really help us in this case, okay? What's the other thing that we know about cyclic quads? What's the other thing we know about cyclic quads, Matrix? Apart from opposite angles adding up to 180. Something about an exterior angle, the exterior angle of the cyclic quad. Ringing a bell? Exactly, Boucle. So the exterior angle of a cyclic quad is equal to the opposite interior angle. Okay. Now, the exterior angle of the cyclic quad, okay, so when we talk about an exterior angle, it has to be an extension of one of the sides. So let me show you here what's happening. Okay, let's just do it in blue, all right? There's one side, there's the other side. Oopsie. There's our cyclic quad. Can you see, guys, that the y-axis is an extension of side BC, which means that this angle over here, angle VCO, is the exterior angle of the cyclic quad, and it would be equal to angle VWB. Now, if you have a look at this angle and the angle that we know is 45, if that's 45 and that's 90, then how big does this angle have to be? It also has to be equal to 45 degrees because of angle sum and triangle. And if angle VCO is 45, it means that VWB is 45 because of exterior angle of a cyclic quad. Does that make sense to you? So can you see now how, like I was trying to say in class the other day, these properties of cyclic quads and quadrilaterals and all that kind of stuff comes into our analytical geometry. So this would be considered a level 3 or complex type of question. Okay, so now here, what do we need to say? Well, first of all, we need to explain why VCO is equal to 45. So we're going to say here VCO is equal to 45 degrees, angle, sum, and triangle. And then we're going to state that angle, what was it, VWB, angle VWB is also equal to 45 degrees because of exterior angle of cyclic quad. Okay. All right, how are we all feeling at this point? Cool. Yay. All right, lovely, everybody. Good, I'm glad. All right, so now let's get down to business. All right, now things start to get interesting. A new circle is obtained. Good, I'm glad to see all the thumbs ups. Thanks, Michelle. Thanks, Kayla, and everybody else. All right, a new circle is obtained when the given circle is reflected about the line y equals 1. Now that is something quite unusual for us in the CAP syllabus. We don't normally reflect over lines like y equals 1 or whatever the case is, but we can. Absolutely, we can. So now we have to say to ourselves, well, if this circle is reflected over the line y equals 1 and a new circle is obtained, what is the new circle going to look like and where is it going to be positioned? So before I go and show you this, I want you to tell me where you think the circle would be. Is it below the x-axis? Is it above the x-axis? Where should I draw it? If I was going to draw a picture of it, where should I place it? It will be an inverse. So can you see that when we talk about inverses, we're talking about swapping x and y around. So it's not an inverse, it's a reflection. So it's like you looking in the mirror. First of all, let me ask you this. Where is the line y equals 1? Is it a vertical line or is it a horizontal line? This line that it's been reflected over. Absolutely. Absolutely. It's a horizontal line. And the line y equals 1, let me see if I can draw a to see whether I could draw a line that was okay. I suppose that'll do. There's the line y equals 1. So if I reflect this shape over the line y equals 1, imagine picking it up. Imagine grabbing that circle up at the top next to W and just flipping it over and putting it down on itself. That's essentially what we're doing, all right? So in other words, and I mean, we don't need it here to be able to answer these questions, but it's going to be situated, it's going to also just peek through there. It's going to be somewhere here. Okay, I haven't drawn the correct size, but that's what it's going to look like. Okay, so it's literally just flipped over itself like that. And this little bit up at the top here was that same little bit that was down at the bottom over there. Does that make sense to everybody? Okay, yes, it is mostly in quadrant number 3. Does that make sense before I carry on? Okay, so it has been reflected over the line y equals 1. Okay, it's not the correct size, but it's in the correct place. Okay, good. All right. So now that we know where it's going to be located and the line that it has been reflected over, now let's worry about going to answer the questions. The first question says, determine the coordinates of Q, the new center of the circle. Okay, so in this situation over here, right, this new center, let's just rub this out. If it's been reflected about the line y equals -1, we have not moved it left nor right. Agreed? We have not moved it left nor right. So that means that it still needs to have its center in the same vertical line as it was. So that means that its x-coordinate is not going to change. All right, its x-coordinate is not going to change at all. Right, so as far as Q is concerned, its x-coordinate will still be -3. Now we need to worry about what its corresponding y-coordinate is going to be. Okay, Boutle, that's a very good suggestion, right? And you are very close, very, very close. But why is Boutle not completely right? Boutle said over here that this should be -4, and I'm going to write it in a different color. Boutle says this should be -4. Why is it not -4? Does anybody know? All right, so there we go, Kayla, because it wasn't reflected about the line y equals 0 or the x-axis. Okay, if it was reflected over the x-axis, 100%, but it wasn't. All right, it was reflected over the line y equals 1. Okay, so it's further up, it's higher up. How are we going to work out how much higher it is? Well, if it was reflected over the line y equals 0 or the x-axis, then we would end up with this outcome, wouldn't we? But it was reflected over a line that was higher up than that. You do need to move it up, but it's not just one unit that you're moving it up. It's actually 2 units that we have to move it up. Absolutely. Okay, so over here, this is now -3 and -2. Okay, why? Why has it moved up another unit? Well, that's what I'm asking you. Why? What's the reason for that? Why does it have to be up another unit and not just 1 unit? This is the part that's difficult to understand, okay? I'm going to get rid of the circle as it is here, all right? And you know what the problem is that when we first reflect the circle, we're not 100% sure of where it is. So what you might be forgiven for thinking in the beginning, Matrix, is that when it is flipped over the line y equals 1, we think that it's going to be drawn like that. Okay, so if it is flipped over the line y equals 1, then the center over here would be at -3 and, sorry, let me get rid of all of that writing there because otherwise it just makes it confusing. Then we would see the center at -3 and -3 if the 2 tangents just touched one another once. Right? But when we reflected it over the line y equals 1, this wasn't actually the case because part of the circle below is now lying in the circle above. So essentially what's happened is that this bit that sticks out underneath over here, there's going to be an overlap. All right, so essentially, if we just took the picture like it was and flipped it over, all right, we would be 1 unit up. But we didn't just flip it over like this, all right? That bit, so if we did, then the circles would be touching one another. They're not touching one another, they are overlapping. So that is why it wasn't just a case of flipping it over, and so that it is they're an external, they're touching one another externally. They're actually, as I was saying, they're actually cutting over one another like this, all right? So in other words, the second circle, oopsie, cuts into the first one. So there's this area of overlap over here, and here is the line that you have reflected it over. So it's actually 1 unit up from where you think that it is. Okay, and that's why it is at -3 and at -2. Does that make sense? You sure? Okay. So if the two circles were touching one another externally, then the coordinates at Q would be -3, -3. But they don't. The circles actually intersect one another twice. All right, so there's that area of overlap down at the bottom. So it's actually 1 unit higher than what you think it is when it's been reflected over the line, y equals 1. Okay, so yeah, we just have to think about that very carefully, but it does make sense. All right, so that is a difficult question. No doubt about that. 2 marks, but definitely a difficult question to answer. Question 4.4.2. Now they want the equation of the new circle in the form da, 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 da. So now as soon as we know what the equation or what this, the coordinates are at the center, it's become easy. Of course, we haven't changed the size of the circle, so r squared is still going to be 10. So this is going to be the circle x plus 3 squared plus y plus 2 squared equals 10, like so. Okay, so that will be that for 2 marks. And then question 4.4.3. The equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the 2 circles. All right, so when they talk about lines drawn parallel to the y-axis, they're talking about lines that are vertical, okay? And the circle, as I was sort of trying to reiterate previously, the circles now intersect one another twice. So I'm going to try and draw that a little bit better again, just to help you visualize what it is that I'm trying to say here. You can draw circles. Hang on, there we go. There we go. Let me draw a circle. Well, mind you, I don't know if that's actually 100% a circle or if it's not. Okay, let's try and work with this guy, okay, and see what happens, okay? So we have got a situation like that. Slightly more this way. That's a little bit better. Okay, that's a better reflection of what's actually going on here. All right, so now your y-axis continues down here. And what you would have is that that point over there would be a reflection of C, and this point over here would be a reflection of B. Look, my circle is not 100% great, but anyway, it does the point. They are talking about 2 lines that go through the points of intersection. So one will go through over here, and the other one will go through over there. That's where the 2 points of intersection are. Can you see that? So a vertical line going through this point of intersection over here, this has to be the line x equals -2, doesn't it? And if this is in the middle, if -3 is in the middle, then by symmetry, the line over here, this has to be the line x equals -4. Okay, so the one is the line x equals -2. The other one is the line x equals -4. Does that help? How's everybody feeling now? Are you okay, Matrix? Okay. Michelle, where did the x values come from? 100%. So do you remember that at v, x was equal to -2? Do you remember that? Okay, so at v, x was equal to -2. So that's where it comes from. Okay, so we know that when that circle is reflected over the line y equals 1, that point of intersection will stay there at where x was equal to 2. So by symmetry, if it's 1 to the right of the middle, then it must be 1 to the left on the other side as well, which is why it has to be x equals -4. Does that make sense? Okay. Now, all this maths. Okay, cool. All right, lovely. So everybody's feeling good about this question. Okay, nice, good stuff. Are you guys ready to go and do some trig now? Or is there any sort of last questions that you'd like to ask me about what we've done here? Why is it negative? Because it is to the left of -3. So remember the x-axis is a number line, Faith. So it goes -2, -3, -4, -5, etc., etc. Okay. So to the left of -3 is -4. %, no worries. Okay, Faith, cool. If everybody's okay, then I will move on and we can go and talk about the trig question. All right, so the trig question is over here. And yeah, just a quick reminder about our compound angle formulae and our double angle formulae. Remember, now that we are in metric, we have to expect these kinds of angles to crop up. Definitely in our identities, in our equations that we're being asked to solve. And so, yeah, pretty much everywhere, all over the place. Was there anything from question 5 that kind of jumped out at you as being particularly difficult? Is there anywhere you'd like me to start? 5.4. Okay. All right. So Thelma says 5.4. Kayla says 5.3. Does that mean that, okay, say, well, that's fine. 5.3, let's start there. 5.1. Okay, Michelle. 5.22. Mercedes says 5.4. All right. Well, okay, 5.3 and 5.4 mostly, absolutely. Okay, well, let's just whip through the others just to make sure that you got the right answers, okay? And then if you feel you want more practice with trig, we can certainly, okay, so proving the identities, yeah, there can be some really nasty ones. Okay, let's have a look at this. Okay, so in question 5.1, they wanted you to simplify this to a single trigonometric ratio, right? So I'm going to write here on the side. So this means applying our reduction formulae from grade 11. So we absolutely have to know what these are. So tan minus x becomes minus tan x because we're working in quadrant 4. We're multiplying that by cos x. Sorry, this is question 5.1. Sine x minus 180. So the other way for you to look at that as though we are talking about the sine of, take the negative out, 180 minus x. And then from that, we are subtracting 1. So these three here are all part of the same first term. So this gives us minus tan x is minus sine x over cos x times cos x, which is cos x over 1. And then over here, the sine of 180 minus x, this would end up being minus sine, sorry, y squared. I don't know, because I'm going crazy. Minus sine x, okay, so because it's 180 minus x, but we have to do a negative angle. And then from that, we want to subtract 1. So these two cancel. We end up with minus sine x times minus sine x, which gives us sine squared x minus 1, which if we take out the negative 1, that would give us 1 minus sine squared x. And now we're using our square identity to get negative cos squared x, like so. Okay, very quick. Your marks here, definitely for using the tan identity, definitely for reducing. There has to be a mark for multiplying. There obviously has to be a mark for the answer. There's one more mark involved here. I don't know, maybe simplifying accurately or something like that. Okay, then in terms of M, if you look at question 5.2.1 first, given that cos 35 is M, they want us to determine the cos of 215. So that was really easy because 215 would be 180 plus. So here we would first have to reduce this to negative cos 35. You have to do that, equals negative M. So a mark for this and a mark for that. Remember, you've always got to write what you get when you reduce. Okay, then 5.2.2, we're getting a little bit closer. So the trick to this question is realizing that the sine of 20 can also be written as the cos of 70. Okay, never forget about your cofunctions. All right, so the sine of 20 can be written as the cos of 70. And of course, 70 is 2 times 35. Okay, so what I would do here is I would say that sine 20 is cos 70. That means that it is, not that you have to write this line, but this is where it comes from, 2 times 35. And then what I would do is I wouldn't worry about sine or anything like that because I'm working in terms of cos here. So I would just go straight to 2 cos squared 35 minus 1, your double angle cosine identity, or at least one of them anyway. And then I would go and sub in. So cos 35 is M, so cos squared 35 must be 2m squared minus 1, like so. Okay. All right, and now we get to question 5.3. So when we look at 5.3, we're looking at the left-hand side over here. And tell me, what do you guys notice about the left? Is there something that you notice in particular? Yeah, absolutely. It's a compound angle. So if I go and fetch this from up here, okay, we can see, look there, we've got cos 4x cos x up here, cos x, cos 4x cos x. So we've got cos. So in other words, it has to be a cosine compound angle because we want cos. And then we've got a plus. Okay, so there's our plus there, and then we've got sine. The only thing that they've done is that they've swapped these two around, and that doesn't matter because the order in which we multiply really doesn't matter. Okay, so this is exactly what it is that they're talking about with this particular question. Okay, it's that compound angle formula over there. All right, so now remember, in order for us to go from the right-hand side to the left-hand side, remember I described it when we were doing trig. It's like a key fitting into a lock. The only way you can unlock it is if it fits in perfectly. So let's just get these into the right order. Then we can do the reversal of the expansion and then take it from there. Okay, so let's get rid of this guy. Let's go and stick him over there, out the way, and we can go back to our question. All right, so we are going to rewrite this as cos 4x cos x plus sine 4x sine x equals negative 0, 7. Now we're going to do the reversal of the expansion, okay? And remember, in this particular case, it's going to end up being cos 4x minus x. So this is cos 4x minus x, not plus, is equal to negative 0, 7. And thus matrix cos 3x is negative 0, 7. Okay, so now they are telling us to do the general solution. Okay, so doing the general solution means we need to develop those formulae that allow us to find solutions when we leave 0 to 360. That's why we do general solutions, because it allows us to find a solution anywhere. All right, so the first thing that we need to take note of is the fact that cos 3x is negative. So in our cast diagram, there are two quadrants where cos x is negative. Either it's negative in quadrant number 2 or it's quadrant number 4. Those are the two quadrants we would work in. All right. And because we've got the cos of an angle, our angle in this case is 3x equals our ratio, it means that we are ready to find our PAA. And if you recall, our PAA or our RA, our positive acute angle, we're not going to use the negative in front of the 0, 7 to determine this, okay? So on our calculators, we would go shift cos, we would pop in the 0.7, and that gives us a reference angle of, I don't know about you guys, but I'm getting 45,57 degrees. Now I need to do a solution in quadrant 2 and a solution in quadrant 3. So in quadrant number 2, not that you have to write that, but I'm just writing it for you, we would say our angle 3x is equal to, in quadrant 2, we use the reduction formula, 180 minus. So it's going to be 180 minus our PAA plus multiples of 360, because that's how often a cos graph repeats itself. Okay, k is an element of the integers. So now let's just simplify all of that, and then we can divide through by 3. So now that means we've got (1, 3, 4, 4, 3) plus k times 360. And now we're going to divide each term by 3. Okay, so that's on the left-hand side, the number term and the term that has the k times 360 in it as well. Okay, so everything must be divided by 3. All right, so this gives us x equals 44,81 plus k times 120. K is an element of the integers. Okay, so I'm just going to move that up. And now in quadrant 3, now in quadrant 3, 3x would be equal to 180 plus is our reduction formula. So 45,57 plus k times 360. K is an element of the integers. And again, we need to now solve for x. Okay, so I've got to add the 45.57 to 180, divide through by 3. I'm just going to do that all in one step. I'm getting a final answer here of x is equal to what? Oh, no, that is correct. Sorry. 75,19 degrees plus k times 120. K is an element of the integers. All right, do you agree? Are you getting the same answers? Okay, cool, Michelle, cool, Tabile. I'm glad that that's making sense. Okay, so as far as question 5.3 is concerned, that's where they want us to stop. All right, they asked us to find the general solution. We've done that. We found the two general solutions. We don't now need to go and sub in integer values for k. They didn't tell us where on the x-axis they wanted us to solve, so we would just leave our answer just like that. Okay. The other thing that I wanted to tell you is you don't have to write k as an element of the integers on every single line. I just do it because it's habit, but you have to have written it at least once. Okay, so sometimes there is a separate mark for that altogether, so don't leave that off. I'm trying to think if there's any other hints that I can give you this question where we normally go wrong. Yeah, and if you do have to divide through by something, don't forget to divide the term with the k in it by the coefficient of x as well. Okay, all right, there we go, all good. Nice, 4 marks. Okay, so that would have to be for that and that, our PAA, and here there has to be a mark for us using our compound cosine angle formula there. Okay, nice. Let's do 5.4. All right, so let's look at this monster. I'll tell you what, before we look at the monster, shall we write the monster down? And then we can have a... Faith, it depends on what's in front of your x. So if you end up at this, so let's say if you had something like in this line here that I'm highlighting in pink. Okay, if you ended up with something like cos x, then your angle is x, so then there's no need to divide. But if you end up with 2x or 3x or 5x or whatever it is, then you would have to divide through by 2. Similarly, if you ended up with something like cos x plus 10, all right, you would need to take 10 away. All right, so if your angle was x plus 10, you would need to remember to take 10 away from the left and from the right hand side as well. But you wouldn't subtract 10 from here because they're not like terms. You would have ended up subtracting 10 from the 180 or whichever quadrant you're in. Does that make sense? Yes, absolutely, Cassandra. Okay, so you don't divide through by 3 when you are working here. So that's a common misconception. And remember, you're working along a curve. Okay, so if you divide the angle by 3, it's not the same as dividing the ratio by 3. Okay, the angle is 3x. So yeah, just remember you're working along a curve. Like another way for me to, okay, even though it's a sine graph, let me just show you what I'm talking about. Okay, so you're working along a curve like that, aren't you? So if I'm talking here about 30 degrees, and this is the graph y equals sine x, 30 degrees. So the sine of 30 is a half, but is the sine of 60 equal to 1? No, it's not. Okay, so the sine of 60 is not equal to 1. So the sine of 30 is a half. The sine of 60 is root 3 over 2. The sine of 90 is 1. So if I double the angle, I'm not doubling the ratio. If I divide the angle by 3, I'm not halving the ratio. Okay, you're working along a curve. All right, and it would be exactly the same thing for the cosine function as well. Okay, does that answer that question, Cassandra? So you divide by 3 at the end when you have got your, when you've got your general solutions. Okay. All right. Let's go back and tackle this nasty looking job over here. Okay, so I think the easiest thing for me to do would be to, it's a pleasure, no problem. Okay, so we've got sine 4x cos 2x. I'm just going to write this down. So on the left-hand side, we've got sine 4x cos 2x. Then the second term is minus 2 cos 4x. Minus 2 cos 4x. Sine x cos x. And that was all over tan 2x. So this is just another question for us to work on. Let's just see how it goes. Okay. When you are solving an identity, you may not move terms. You're not solving an equation, all right? So you're proving that the left-hand side equals the right-hand side. So because of that, you are not allowed to move terms from the one side to the other. Okay, if you did that, it would be wrong, and you would end up losing marks, or they wouldn't mark it any further depending on whatever you've done. Okay, so you are not moving terms. Okay, you've got to work with either the left-hand side or the right-hand side separately and arrive at the same conclusion. Sometimes we just work with the left-hand side and we get what's on the right. And sometimes we have to work on the left and the right to get it into another form that they're both equal to, and then conclude that the left-hand side equals the right-hand side. Okay, in this situation, we don't have to do that. We can if we want to, but we don't have to. And really what it comes down to is looking very carefully at what we've got in the numerator. And all they've done is they've just moved things around. So what I'm going to do is, if I keep the first term, so that's this guy over here, if I keep the first term the same, okay, we've got sine 4x cos 2x. Now this 2 over here, it means 2 times cos 4x times sine x times cos x. So if I take it and I put it in there, does it matter? No. So now I'm going to say minus cos 4x times 2 sine x cos x over tan 2x. This gives me sine 4x cos 2x. Whoopsie, 1 equals, I don't know. To write minus. And now 2 sine x cos x is what, matrix? This is sine 2x. So we end up with cos 4x sine 2x. All over tan 2x. What's in the numerator now? Yes, cos 2x is an identity. It is. But before we start expanding and making this into something that's really, really long and very, very difficult to work with, we've now got it to this. So before we go and start working in terms of x, all right, we don't always have to work in terms of x. It is possible for us to work in terms of 2x and 4x and whatever the case might be. Can you see that this is a compound angle? Exactly, it's a compound angle. All right, so let's go and fetch this guy from, let's go and fetch this guy from up here and drag him down. Stick him over there. All right, so sine 4x cos 2x. Okay, so sine 4x cos 2x, sine 4x cos 2x minus cos 4x sine 2x. Okay, so it's this, guys. Does that make sense to everybody? Yes, exactly, Mighty. Okay, 100%. Sine A minus B. Okay, sine A minus B. So if they've put 4x with 2x together. They're treating the 4x like it's the double angle. Okay, so in this case, resist the temptation to apply all these double angle identities in order to get it in terms of x, and just work with it the way that it is, okay, and then see from there what's going to happen. All right, so now that we've identified that this has to be a sine compound angle, we would end up with a sine of 4x minus 2x, right? All over tan 2x. So this gives us sine 2x over tan 2x. And tan 2x is sine 2x divided by cos 2x. That's our tan identity. So now we've got sine 2x divided by sine 2x over cos 2x. Let's just move down. Hold on a second, matrix. Let me just yank this and pull it down here. And now when we work with fractions, we've got to tip in times. So that means we're going to keep the sine 2x that was in the numerator where it is. We're going to change the divide into a times. We're going to put cos 2x at the top, and we're going to put sine 2x at the bottom. All right. This guy divided by that guy is 1. This gives us cos 2x. And from our formula sheet, we can see that cos 2x is cos squared x minus sine squared x. Okay, so therefore it equals the right-hand side. It's a pleasure. That's my job. Okay, let's just check that it does. Yeah, okay, there we go. Let's just move it back there. Okay, so yeah, when you see cos x, when you see 4x and 2x together, I know our tendency is to want to write everything in terms of x, but that isn't actually what they want us to do with the question. Okay, how do you feel, matrix? Is this making sense? Are you happy? It is, Kanyisile. It is easier than we think, most of the time. Good, guys. Oh, that's lovely. Nice, Michelle. I'm glad to see you 100%. Happy, feeling a little more hopeful. Awesome. Okay, now that unfortunately is the end of what I had wanted to do today. All right, but what I did go and do is I went and grabbed a grade 11. There's lots of hope, can you see? Lots and lots and lots. There is a grade 11 question from analytical geometry, which I've stuck down here. But if that's not going to help you with the upcoming exams, then I'd rather leave that. Do you want to do more trig? Because I can go and grab a trig question very quickly. Trig is normally, okay, all right, that's fine. So let me just grab a, okay, all right, I've got a nice difficult trig question we can do. So just give me 1 second. I'm just going to get rid of this guy and that, and I'll be 2 seconds, just 1 minute. Okay, I'm nearly there. Okay. Where are we? There we go. So I think this is probably a better use of our time, come to think of it. Okay, so here is a sort of slightly more, well, not slightly more, but it's also a difficult question. The first one is similar to one that we've just seen, where you have to simplify things to one trigonometric expression. Okay, what I like about this particular question is that it's also got one of these where without using a calculator, we need to determine the value of. So I'm thinking we could start at 5.2, or do you want me to just work through the whole thing? Are you happy with that? Maybe just work through the whole thing. Okay. All right. I'll tell you what. All right. Cool beans. Can you see you saying 5.4? Absolutely. We'll get down there. All right. So let me move this over and let's go for it. Okay. So in 5.1, this is sort of supposed to be what would be considered the easier question that we're all supposed to be able to do. And hopefully you are feeling that way about it. Okay, question 5.1. So we've got sine x over, and then what I'm going to do here is I'm going to write cos x, and then I'm going to straight away, I'm going to write tan x as sine x over cos x. Going to save us a little bit of time, because now we can see straight away that that's going to cancel, and then that one will end up cancelling as well. Does that make sense to you? Anyway, we don't have to do that all in one step, but that's what will eventually happen. Then we've got plus sine 180 plus x. That is quadrant number 3, where sine x is negative. So we have to write this as negative sine x. And it's being multiplied by cos 90 minus x, which is one of our co-functions. So if you recall, the cos of 90 minus x is sine x. Okay, so as mentioned before here, the cos x divided by the cos x is 1. Sine x divided by sine x would leave us with 1. So the first term actually has a value of 1. It's not 0. Okay, when everything cancels, it's 1. It's not 0. And then here, sine x times sine x is sine squared x. But because we are adding a negative, it's going to be 1 minus sine squared x. All right, which gives us cos squared x, like so. Okay, and it's out of 5 basically to help you. All right, the marks here would be allocated for your tan identity. Definitely a mark on the co-function. There would have to be a mark here on the minus sine x. There would have to be a mark on 1 minus sine squared x, and there would have to be a mark there on cos squared x as well. Okay, let's fly. Question 5.2. Without using the calculator, determine the value of. What do you notice about the numerator in this question matrix? It looks similar to something, but there's just a little something that's wrong with it. It does, Aisha. It looks like, absolutely. It looks like cos 2x. It looks like, yeah, like a cos double angle. But the problem here is that the sine squared 35 is the one that's positive, and the cos squared 35 is the one that's negative. How do we rectify? There we go, Aisha answered the question before I even asked it. Take out a negative. Good, Aisha, lovely. So taking out a factor of -1 yields this. Good job. At the bottom, we've got sine 10, cos 10, and then there's 4 in the front. What do they think? What are they getting at here with us? In the denominator, what do we think this is? Is it a compound angle? Is it a double angle? The one I've highlighted in pink. What do you guys think? Yeah, absolutely. 4 can also be what? Indeed, it's a double angle. All right, because 4 can be written as 2 times 2. Okay, so that's what we're going to do here. 2 times 2. Sine 10, cos 10. All right, so now at the top, we have got negative cos 70. Does that make sense to everybody? At the bottom, this bit over here that I'm highlighting in pink, that is going to become sine 20. And the cos of 70 and the sine of 20 are the same thing. Okay, they are co-functions. All right, so if I can change sine to cos or cos to sine, where did the sine go on the top? It didn't go anywhere, Kayla. I applied my double angle formula. Okay, so let me grab this and show you what I've done. I know that's a very common question. Where did the sine go? Okay, so here, Kayla, this is what I was doing. All right, so I have written what I had, this cos squared 35 minus sine squared 35. That's this over here. All right, in my next line, I did that. Okay, cos 2a. Okay, so 2 times 35 is where the 70 came from. All good, Kayla? Cool beans. All right. And as I was saying before, you can rewrite the cos of 70 as the sine of 20. So that would be minus sine 20 over 2 sine 20. And that guy divided by that guy is 1. So that means our final answer here, matrix, would be minus 1 over 2. Okay, and we definitely did this without the use of a calculator. Okay. Right, so I'm sorry if I'm working a little bit fast. I just wanted to make sure that we got through all of these questions in the time that we have left. Maybe I must just not speed too much. Is that okay? Am I making sense? Is there anything anybody wants to ask me? You all good? Yes. Yeah, Michelle, that would be a difficult one. I mean, the thing is, what you could do is you could write sine 20 as cos 70 as well. But I mean, it's the same thing at the end of the day, isn't it? So this is why in matric, your co-functions are so important. So if you've got a cos and you've got a sine, and they're complementary, they add up to 90, then you've got to be thinking about your co-functions. Okay. Yeah, just another thing that's very, very important. Everything's very important, isn't it? Okay, 5.3. Yeah, Ayuvuya, let's do it. Let's smash the beast. Okay, nice, difficult question, isn't it? So this is proper problem solving. Goody. Okay, question 5.3. Let's do it. So they have given us that cos 26 is equal to m. So this is ratio in terms of a letter, right? All good and well. But what they want us to define is 2 sine squared 77 in terms of m, right? So let's just talk about cos 26, right, is equal to m. And this is, again, this is your co-functions that are so important. If I wanted to write the cos of 26 as the sine of an angle, what would it be the sine of? Although I don't think that's going to help us in this case. 64, yes. Okay, no, that's not it. Okay, it's something else. All right. What it is this, sorry. Okay, so 26 is 2 times 13. Okay, and 13 plus 77 is 90. That's the connection here. Yeah. All right. Sorry, it's not, we're not going to rewrite that as a sign at all. Okay, it's going to be the cos of 2 times 13 gives us 26, and that would be equal to m. All right, so now we've got a choice. We've got 3 different ways that we could write the cos of 2 times 13. We can write it in terms of sine and cos, in terms of cos only, and in terms of sine only. All right. Here in our question, we have this only in terms of sine. So let's write cos 2 times 13 in terms of only sine in this particular case. All right. So in other words, I'm going to write it as 1 minus 2 sine squared 13 equals m. Everybody happy with that? Sure, Ayavua. All right, so what I'm doing here, let me go and grab my formula sheet. Let's grab this guy and bring him down here. What I'm doing is I can see up at the top here, I've got an answer of 2 sine squared 77. So I'm trying to work in terms of sine. All right, so that's why I'm doing what I'm doing over here. All right, so I'm trying to work in terms of sine only. So when it comes to a cosine double angle, all right, I can write it in terms of cos and sine, cos only, or sine only. So what I've done here is I've chosen to write it as this last one over there, as 1 minus 2 sine squared a. Does that make sense to you? If I wanted, okay, the other thing that I could do here as well, another alternative here, would be for me to work in terms of cos. So I could, if I wanted to, or if I want to, I can write this as 2 cos squared 13 equals m. That actually might be faster for me. Okay, so I can write it as either one of these two. Okay, are we happy with that? We're just applying our cosine double angle. Right. Now, if we look at the cos of 13, the cos of 13 is the same as the sine of 77, isn't it? Because they are co-functions. One is cos, the other one is sine. Are you happy with that? Sorry, there needs to be a -1 over here. Sorry, I missed out on that. Here, I beg your pardon, is when I wrote 2 cos squared, I wrote 2 cos squared 13 equals 1, but it's not. It's 2 cos squared 13 minus 1 equals 1. Sorry, so I've just slipped the -1 in over here. So now what I'm doing is I'm writing this cos squared 13 as sine squared 77 minus 1 equals m. And now I want to make 2 sine squared 77 the subject of the formula. So what I'm going to do is I'm going to leave 2 sine squared 77 on the left. I am. Okay. I'll be with you. Thank you. So I'm going to leave the m on this side over here. I'm going to take the 1 over to the other side, and thus it will be equal to m plus 1. That's actually going to be the easiest thing for me to do with this question. Does that make sense to everybody? Cool. Cool. Oh, nice. So can you see, it's also like we look at it at first and we think to ourselves, oh, that's so difficult. What are they talking about? What does it mean? And in actual fact, it's a combination of complementary angles and double angles. Okay, they've got to be asking you to apply what it is that you already know. Okay. There we go. All right, so 4 marks. I imagine for this question, there must be a mark for using, we could have gone that way, but that would have been longer because we would have had to use our co-function at the end. So there must have been a mark for writing cos 26 is 2 cos squared 13 minus 1. There has to be a mark for writing cos squared 13 as sine squared 77. I don't know where the 4th mark would have been. I'm not sure. Okay, all right, but there
would it not have been for figuring out that cos 26 was actually a double angle of 13? I think that's quite.
Maybe, probably, yeah. I think you're right. Because I mean, that was actually where we first started, was figuring out that it wasn't the sine of 64. We were going to work with a double angle. Yeah, that makes sense. 100%. Thanks, Coco. All right. Sure. Okay, one more question to do, and then we are done for today. All right, so now, guys, have a look. Question 5.4. What are you looking at, okay, when you look at the sky over here? Okay, you've got your formula sheet right next to you over here. It's there. It's one of these. It is a hopefully you can see it, that it is a compound angle. Okay, so we've got sine, cos, and we've got a minus, all right? So you've got sine, cos, the minus, cos, sine. Okay, so that means that it has to be this. It has to be sine A minus B. All right, so in 5.1, is everybody happy with that? Compound angle, indeed it is. Okay, so in 5.4.1, we've got the sine of x plus 25. And from that, we have to subtract 15, okay, using our sine compound angle formula. Right, and they've told us to determine the general solution if f of x is equal to tan 165. So that's our ratio. So this is equal to the tan of 165. Okay, so let's first of all simplify what we've got. We've got the sine of x plus 10, agreed. And that's going to be equal to the tan of 165. So this has to reduce, right? And we are allowed to use a calculator here. And it would reduce to negative tan 180 minus 165 would be 15. So negative tan, oopsie. Negative tan 15. All right, so that means that sine x plus 10 is equal to tan 15 okay, and your ratio is a weird number. It's negative 2 plus root 3, which you can, if you want to, write that as a number out in full, but I mean, it's going to be long and tedious and unnecessary. What's important to note is that it's negative. Okay, so again, if we quickly draw our cast diagram, CAST, our ratio, highlighted in turquoise, is negative. In which two quadrants is sine x negative? It is negative in quadrant 3 and quadrant 4. So that's where we need to do solutions, in quadrant 3 and quadrant 4. Okay, so now in quadrant 3, our angle is x plus, oh, sorry, hang on a second, I haven't found the PAA yet. All right, let's just do that quickly. Okay, so now our PAA, remember we're going to leave the negative off when we find our PAA. All right, so we're going to go shift sign, pop in our ratio, and I'm getting a PAA of 15,54 degrees. Okay, so now we're working in quadrants 3 and 4. Quadrant 3, first of all. Our angle is x plus 10, and it will be equal to, sorry, Michelle, tan. I didn't get that. Maybe I made a mistake. I don't think so. Coco, Nicole, could you help Michelle in the chat? Unless I've made a mistake, which I don't think I have. Yeah, I didn't. I mean, I do make mistakes. I make lots of mistakes, but I didn't think I had made. Oh, then you press shift. Oh, okay. All right, cool. All right. I'm glad that you're okay. All right. So now, third quadrant. X plus 10 is our angle. In the third quadrant, we have to use 180 plus 15,54 plus multiples of 360. There we go. So now you can see this is what we were talking about earlier. So now we've got to add 15 to 180 and then subtract 10. So I don't know about you guys, but I'm getting 185 comma 54 plus k times 360. K is an element of the integers. That is our one general solution. Our other one in quadrant 4 now, we have got x plus 10 equals 360 minus. And now I'm getting 334,46.
Ma'am,
did I make a mistake?
Yeah,
I think I did. Sorry.
So I think on the first one, on the quadrant 3 one.
Sorry,
right?
yes, I beg your pardon. So it's 180 plus 15.54. Thanks, Coco.
No, ma'am, I think we're the ones who are not seeing it quite, because that is going to be 180 plus 15,54. That would give us 195 minus 10. That would get us back
is
to
185.54. Yeah.
Yes, ma'am. I think, guys, remember that plus 10 will come over and become minus 10. So I think we were all a bit confused there.
Oh, okay. All right. Okay. No, but I do make mistakes, and that's why I'm so glad I've got your eyes to tell me when I'm wrong. I know at school, I think the kids, these students here, I've heard this 1,000 times at school. I'm like, yeah, I did that on purpose just to see who was paying attention. And then all the boys are like, oh, yeah, whatever. Anyway. Yeah, can you see that they don't think I'm very funny? They think I'm a wicked witch. So, but it's okay because they're not really as nice as you guys on here anyway. So, shame I shouldn't say that about them. Some of them are very sweet. Okay, now where were we? We were busy finding a general solution. Okay, so again, we've done that. We found our general solutions. They don't want us to do anything else. Solving somewhere on the x-axis or any such like, so that means that's fine. Okay, so now we have got exactly 5 minutes left for us to do the last question, and then we can say goodbye. All right, so now they wanted to know, they wanted us to determine the values of x in the interval between 0 and 360, for which f of x will have a minimum value. Okay, so now remember f of x, This is question 5.4.2, if memory serves me correctly. And we agree that f of x is the function sine x plus 10. Do you agree? Yeah? Okay. So this is our normal sine function, but it has been translated 10 units to the left or right matrix. That's it. Okay, you guys are too clever. Okay, all right, so it has been translated 10 units left. Cool beans. So now, if we think about our normal sine graph, okay, between 0 and 360, we would normally have, they wanted to know the minimum value, okay, so we would normally have a minimum at 270, isn't it? That's normally where we would get our minimum of -1. But because we have moved 10 units to the left, this whole graph has shifted 10 units to the left as well. So in other words, our minimum is now going to be occurring at 270 minus 10, which means that it will happen at 260. Okay, so the minimum value of x, for which f of x has a minimum, the minimum will be at 260. Okay. Everybody happy with that? Cool beans. Good, good. Well, I really hope you don't understand. No problem, Maite. Where did I lose you? Where do you not understand? So this is the graph. Okay, so this is the graph y equals sine x. Okay, so that's 0 and 0. Here is its maximum at 90. First x-intercept at 180, minus 270, and there it is back at 360 again. Okay, remember, it's a sine curve, right? So they're asking us to work between here and here. But they're telling us that this graph has been translated 10 units to the left. So imagine if I could take hold of those pink lines and I could move it 10 degrees to the left-hand side. Okay, so in other words, what it would do is it would follow the same curve, but it would be like that. Okay, it would have shifted 10 units. So instead of it starting here at 0 degrees, it's now starting here at minus 10. So instead of this maximum being at 90, the maximum is now going to be at 80. This x-intercept is going to be at 170. This minimum over here is going to be at 260. This x-intercept over there is going to be at 350. So the minimum value, now that the graph has been translated 10 units to the left, is now at 260 instead of at 270. Okay, does that make more sense, Maite? It's a pleasure, Kanisile. Cool. All right, so that's unfortunately our time up. Are there any other questions that you guys would like to ask? Oh, Cassandra, you know what? It's just because we have had lots of practice. It's not because we know something that you don't know. We've just been doing this over and over and over again. So that's why it's easy to make it look easy. But believe you me, it was difficult for us too once upon a time. You've just got to keep practicing. Okay. And coming to Watobe.
Yes.
Yes. It's the greatest pleasure. All right. Kulani says, how did you get the PAA in 5.4.1? Okay, so Kulani, you would have gone, first of all, what I did on my calculator is I took -2 plus √3 and I multiplied it by -1 because I wanted a positive answer. Okay, and then you've got to go shift sine, so that's arc sine, and then you're going to take this value and you're going to pop it in. Okay, and then you'll get that. Okay. Oh, okay, sure. So Aisha, you're also asking me to go back here. Okay, where did I lose you, Aisha? Question 5.4. What do you want to know?
Aisha, would you like to unmute and ask your question?
Hi, ma'am. Sorry, what I meant is that may you please go back to where the questions are so I can take a photo of it. Yeah.
Oh, sorry.
That's okay.
There you go. Is that okay? Like so?
Yes.
Awesome.
Okay. Thank you.
It's a pleasure.
I think that's time, Lee. I think we're going to have to go.
Unfortunately, yes. Unfortunately, it is time. Okay, Matrix, thank you so much for all your participation and for being such an amazing group. I know Nicole and Coco and I love spending this time with you, so we hope you find it enjoyable, and we'll see you on Tuesday.
Well, you'll see Nicole and